All right, everyone, and welcome back. We have Chris here from AWS, and he's going to be sharing a little bit about machine learning in the time of COVID. So I'm actually going to stop sharing, and he's going to take over on his screen. Welcome, Chris. If you want to go ahead and introduce yourself.
All right, thank you, Brianna. I just have to do the mechanics here of sharing my screen.
No problem.
Just need a moment to do that. While I'm doing that, I want to thank you for inviting me to present this morning and say hello to my very good friends in Louisville and Indianapolis and Cincinnati and Nashville for that matter. And that area is just really won my heart when I was out there. So can you see my screen?
Yep, we can see your screen.
All right, cool. And that is New York City, the city I love. And now maybe you can see my presentation. Are we ready to go here, Brianna?
Yep, you are good to go.
Okay, well, thank you very much. And once again, thank you for the opportunity to present here at this very important time. So my name is Chris Skrinak, and I'm a partner solutions architect and the global machine learning segment lead at AWS. My day-to-day job is pretty awesome. I am interacting every single day with usually at least 2 or 3 Fortune 500 companies and many growth partners. So what I mean by partners is I specialize in working with consulting partners, the big GSIs like Deloitte and Accenture, but also regional and specialty consulting firms such as Vsoft. And also my attention is not just limited to the United States. I have a presence around the world, including in Europe and Asia, places like Singapore and India. So I have really what I call the front seat on the roller coaster of AI and machine learning, and really just software development in general. It couldn't be a better place to be. To my credit, I have a number of patents in automated movie making. The position I was in before arriving at Amazon was at GoPro, where I started using TensorFlow, which, believe it or not, at the time, I just didn't even think of it as AI. I just thought it was a computer vision library. But if you've ever used the GoPro app and have made movies, I was involved with a lot of the very early architectural design of some of those products. So what I'm going to talk about today is, number one, what is machine learning and how do you use it? And how are the automation processes that are enabled by AWS providing essential services at this time of crisis? I'll also say that we're in a period of prolonged crisis. I mentioned some of my international bona fides in my introduction here, but I would like to add that I see this going on for 2 years. So I don't see myself returning to doing any kind of in-person one-on-one work in Tokyo or Singapore, as I mentioned earlier, for at least another 1.5 years and very much 2 years. If that's not the realization that you have, then maybe in the Q&A section I can offer some of my insights, some of the feedback that I'm seeing in this position that I'm lucky enough to have at Amazon that's giving me that insight. I'm going to share with you the details of what we call the machine learning stack at AWS, which is the broadest and deepest set of machine learning capabilities available today. I'm also going to talk about how you take those from research and development and turn them into automated workflows that are an essential aspect of continuing operations, what we now call ML ops or machine learning ops. And I'm going to cover some use cases that matter now. You may be familiar with the Turing test, that test that is, you sort of have a blind test and you're trying to tell whether on the other end of your interaction, whether that's on phone, computer, or some other electronic situation, or even mechanical and spatial AR today, whether you're interacting with a computer tonight or not. And, I'd like to add that it's a little bit of a false comparison where I'm seeing machine learning happening today, and where it's being applied is not in replacing a labor force or replacing humans, but more on augmenting and adding power to those situations. And in that process, we're actually creating dozens, if not hundreds of new positions and new jobs and new responsibilities. So getting a head up on what machine learning is and how to use it is not only benefiting yourself, which it certainly will in the next 3 or 4 years, but also creating dozens, or like I said, hundreds of opportunities as you begin to leverage the capabilities of others. We really don't know how deep this rabbit hole goes, but we do know that with the numbers of people that are on the planet, the resources that need to be shared and recycled and renewed, machine learning and data itself is going to play an absolutely essential role in survival. So let's start with the absolute basics, and that is that AI is a misnomer. If you look at applied AI today, now there is something called general artificial intelligence, and it's being developed in universities, but it is really just research phase. I'm going to focus on applied AI and what applied AI does today. And in a word, it is prediction. If you were to say, what is the #1 thing that AI does today? It helps you better, that AI helps you do today, it helps you better predict. So machine learning is really all about data. I frequently use this expression, data writes code, not programmers. So this is an extraordinary revelation once you really begin to get into AI and understand what it does. In fact, the programming word that's used if you're using Python or some other language that's developing a machine model is fit. So what exactly are you fitting when you create a model? You're fitting the data that you have aggregated from highly reliable sources. You understand the lineage. Where did that data come from? How was it versioned? How did you call out columns and create new features that really created the predictive capabilities that are in the code that you're developing, that are in the model that you're developing? At the end of the day, the #1 area where I'm finding executives are having a hard time really understanding is that their education in software development was really all about deterministic programming. So when you say to somebody, what is the capital of Delaware, you expect to have a single answer come back. But in fact, you're going to get an answer with a 99.9% probability that says it's Dover. That leftover bit is Wilmington or some other place. But the reality is that you're always dealing with predictions and probability. And once you get your arms around that, you begin to do 2 things. #1, understand the role of probability and statistics in the way that we operate our businesses, but also #2, avoid dramatic mistakes. Now, data is writing this code. You're fitting that data to an algorithm that produces a function. Once you have that function, it is part of the software development lifecycle, and it needs to be managed just like every other piece of software that's in your environment. The cloud is creating unprecedented capabilities to manage that data, whether your data is coming from just your server logs or coming from IoT sources, cameras that might be in the workplace or on the manufacturing floor. The cloud is a place where you can suddenly aggregate this data and create relationships, especially using technology called deep learning, that creates unprecedented insights that were simply not capable before. Deep learning in particular is really what people are excited about today. It's really where the rubber's hitting the road in machine learning and what's called AI. And in deep learning, there's three principal use cases. Number one, media capabilities, which I'll dive into. Insights that are capable from those correlations of data that were simply difficult to get to, let's say, in the past, and optimization. So let's look at media capabilities first. We're all used to now talking to our phones and having it translate speech to text, text to speech. That is just something that we're increasingly expecting. When we ask a question in our search engines, we expect our natural language to be parsed, understood, and translated perhaps into many different languages. Computer vision is an essential aspect of every business today. A report that I read a few weeks ago said that 80% of all retail personnel's time is spent simply doing inventory. What if you can shift that inventory, that simple counting of what's on the shelves and what's in inventory, to customer attention, customer training, customer obsession. Using computer vision today, we can detect scenes, we can detect objects in those scenes. That can predict danger, it can predict all kinds of opportunities in your business. In your own way, I'd like you to ask yourself, what do the folks you work with use their eyes, ears, and mouth for? I present that question, like I said, in a context that makes sense when I'm consulting with my partners. And it leads to some very interesting discussions, opportunities that were simply impossible a few weeks and months ago, but now are possible with computer vision and natural language processing through deep learning. The insights that are capable through microsegmentation, creating algorithmic personas, they create the most personalized experiences that we have online. So what do I mean by that? Well, with traditional marketing, what you would do is try to get to know your customer by generalizing. You would say, let's find 4 or 8 personas that are very typical customer experiences. And we would say, like, let's say Jane is a typical customer. She lives in the Midwest, she has 2.5 kids, has a Starbucks non-caf decaf mocha Valencia with whip, and shops at Lululemon. All right, those are all behavioral characteristics of this persona that are relevant to your industry. But when you take her click data, when you take her actual purchasing behavior and add to it demographic data, data that's available both from free government on-sites and from commercial websites, and put that together in a technology called clustering, you can now create micro segments that create relationships that were simply invisible before, but now they're front and center. So that hypothetical persona, Jane before, is now component 59. And you know a lot about component 59. When she shops, for example, for that next yoga pants, you also know what kind of boots she wants, what kind of watch she wants. Now, obviously, I'm referring to an online e-commerce experience, but that translates into every electronic experience. The better you know your customer, the more you can aggregate, the better you can create highly targeted campaigns. When you meet them, you can talk to them electronically now that is much more direct, something that identifies with them much more closely than you could in the past. It creates new markets and really uncovers hidden opportunities that simply weren't available before. Your top competitors who have invested in this technology are doing it today. So that's just a bit of a head up. Last but not least is optimization. In this time of COVID, I am continually met with frustration when I try to get something very, very simple, sometimes just cables or things that I need for the office. The supply chain is not meeting peak demand. There are spikes out there that, excuse me, are easily solved using deep learning, algorithms like Deep AR that can take your supply chain and very highly and efficiently predict where your outages are going to be, so you can get ahead 2 or 3 weeks, 2 or 3 months ahead in your supply chain predictions. That has enormous impacts on the bottom line through capital allocation and reducing unnecessary costs. So I'm going to go back to data. Those are the exciting use cases, but let's talk about the infrastructure at AWS and how that works for a moment. First of all, it starts with data, so understanding that the cloud is not a disk in the sky, that mechanisms like our S3 service where you can store data in the sky, and it is in the cloud, and it is connected intelligently and can automatically kick off processes that update all of those use cases, all of the data for those use cases, all of the analytics for those use cases that I just mentioned. Generally, we call these data destinations a situation where you're either rehosting, replatforming, or re-architecting the business that you have today. I'll stick with S3 because S3, I call it the spiritual home of AWS. It's really where your data ends up and becoming a living, acting organ within your infrastructure. Now, what we typically think of when we think of data are databases. And we've been trained and we're habitually thinking of data in terms of tabular rows and columns. That's the relational database model. But increasingly, data is now matching the data structure of its sources. Key value pairs with database sources like DynamoDB are the #1 places that companies begin to store their data for fast access and for fast acting when their users are in their applications. In-memory databases like Elasticache increase that performance by creating, for example, real-time leaderboards or real-time pricing for products to make sure that you're not leaving money on the table or leaving customers out. Neptune is our graph database, which creates relationships not only between social networks and your customers, but it's a long-time data store for personalized relationships between the products that you sell, the inventory that you're purchasing, etc. DocumentDB is the way that companies like Airbnb, Uber, and Lyft are able to immediately personalize your content when you bring it up on the phone. We have a way now to take millions, tens of millions of records and have immediate personalization in your app through DocumentDB. Time series data, which is critical in manufacturing and IoT, is a very different data source from everything that I talked about in the past. It requires special requirements not only to keep costs down, which time series database at AWS does, but also to create immediate access for analytics. And last but not least, and definitely not least, is blockchain. If there is one fundamental underpinning to capitalism in general, it is trust. And the ability for QLDB with a blockchain ledger to have universal, immutable data stores that are validated by anyone using the database are absolutely essential to our growing electronic economy. Now, those are all the building blocks. What happens when you put them together in a system that automatically renews? And if you take a look, and we obviously don't have time to do that here, but if you dig deeply into this process of when changes are detected in your data and how that can kick off automatic model rebuilding. It can verify and make sure that side effects are not negative when put in production, but that are beneficial, that prediction is actually getting better. We have all the processes ready for you to go today at AWS. So what is this infrastructure at AWS that's so deep and broad? We generally describe it as the ML stack, the machine learning stack, and it's divided into 3 layers. I look at the layer on the top as sort of the icing on the cake. This is where you have no need really to learn what is machine learning, how do I build models from scratch, what are all the fundamental tools like TensorFlow and PyTorch, etc. On those fundamental categories, those fundamental use cases that I mentioned before, computer vision with media, speech to text, text to speech, search for natural language processing, chatbots, the top layer of AI services that we have at AWS are ready for you to use today. You can access them through GraphQL, through REST AI. You can integrate them into your existing apps because they all take an API first, an API forward approach to integrating into your software. You know, we have something on top of this that we sometimes call the 4th layer. The very last item on the top right there, contact centers, and one in the middle there, Kendra. They really take all these services underneath and create complete solutions. So contact centers use Contact Lens for Amazon Connect, which supplement a contact center with a vast number of AI services. And Kendra, which I'm going to get into in a little bit more detail later in how we've used Kendra to help COVID research, uses natural language processing, text analysis, optical character recognition, etc., all of the layers below to make it as simple as just dragging and dropping your data into an S3 bucket and immediately making it searchable and optimizable. Now let's move down the Christmas cake here, or birthday cake as you might have, and talk about the middle layer, which is generally called SageMaker. SageMaker is a highly comprehensive tool set for building AI models. It takes everything from taking your data sources, cleansing the data, working on it with your data scientists and your analysts, and deploying with one click models that are immediately ready for production. The bottom layer might be what you've traditionally thought of as AWS. That's the fundamental infrastructure, the compute services, all of the software layers that make all of that happen. So that's the ML stack. And what's happening at AWS right now is tens of thousands of customers are using all of these tools today to get that in production. Now, a lot of this has grown out of our experience in Amazon retail. So if you're an Amazon retail customer, you know already that we have a number of insights that personalize the shopping experience there. If we were to say, after you searched for a book or some kind of movie or some clothes, if we were to immediately just present to you recommendations that were the most popular, that would be an absolute fail. The more that you use the services at AWS and the more that you use the services that we've enabled for you at AWS, they're the exact same services that are used on Amazon retail. So we know a little bit. We have more than 2 decades of experience refining those processes. Now, what delivers that to you is, of course, our fulfillment automation and inventory management. We have a number of research projects that are going on now with drone delivery. And we're working in spatial as well right now. Of course, you're familiar with Alexa, which is available not only on your phone and on Alexa devices, but on a number of third-party devices. And if you've ever had the chance to walk into any of our Go stores, you know we have this customer experience where you simply walk into a store, take it what it is that you want, a sandwich, a soda, etc., and walk out the door. And as soon as you're outside the door, you see, oh, well, I guess I got to pay for this. I didn't just shoplift. A couple of key use cases that I'd also like to highlight are the National Football League. The National Football League, of course, we're all looking forward to seeing what the season looks like, the COVID season. I'm a big football fan. I made a football movie actually with some colleagues called The Perfect Effort a few years ago. So I'm really paying attention to this. But there are 180 million fans just like me worldwide, and 17 million of them trek out to stadiums this season, and they're the ones we're concerned about with COVID. The NFL has been keeping game statistics since 1920, and it's been showing standard stats for the past several decades, such as yards passing, yards rushing, catches, tackles, etc. But these stats represent only a tiny fraction of the 2 terabytes of data the league collects each week from the over 1,500 hours of play time. And they saw the potential to use this data to create a new line of predictive stats. So the NFL teamed up with AWS to transform how football is analyzed, played, coached, etc. Through RFID tags that are attached to players' shoulder pads, the NFL now collects large volumes of tracking data like location, speed, acceleration, etc., and has created the Next Gen Stats program that you're familiar with if you've seen any of the games. I'm going to move quickly now to highly regulated industries like finance and healthcare. With Thomson Reuters has created an internal platform called the Secure Content Workspaces, and that enables data scientists and to developers across the company to access data in compliance with the company's security standards. At AWS, security, compliance, privacy is our top priority, and we always put it first. Thomson Reuters, when they created secure content workspaces using Amazon SageMaker, was able to eliminate the need for data scientists to deal with access permissions, network security, user roles, and focus on their job. So I want to just highlight a bit here what that architecture looked like. And as you can see, these AWS elements that begin with those S3 buckets that touch on SageMaker for model building, model training, and model hosting are the key elements for deploying this. Now, I'd like to end by talking just a little bit about Kendra. As I mentioned, Kendra is kind of this fourth layer application that is really using every one of those AI services in combination to help your users use natural language processing. If you can right now in a separate window, and I think it's Command-Control-Shift-F to take you out of full screen, go to this bit.ly link. It's bit.ly/cord-19, and you'll see Kendra in action. What we're doing here is we've enabled researchers around the world to simply drag and drop, as I mentioned before, all of their research into a database that makes it very easy to use natural language processing to discover other research that's going on right now with Kendra. Now, Kendra uses connectors for popular sources like S3, but also SharePoint, Salesforce, ServiceNow, RDS databases. Sort of the first logical use case for your company is to take all the crap that you have around HR, throw it into Kendra, and instantly make it accessible to your employees so they don't have to search a half a dozen places to find the data that they need to be supported within their company. So I hope I didn't go too long there. I want to leave a little bit of time for Q&A, but I do want to emphasize now is the time to act. As I mentioned at the very beginning of this presentation, we're looking at 18 months to 2 years now of a wholly different situation. Getting your leg up on AI and machine learning right now, discovering the options, will be paying benefits for years to come. And now's the time to do it, whether you stay on the top level of the stack, which is highly powerful at AWS with our AI services, or go all the way down and really learn how to code from scratch some of this stuff. Now's the time to put machine learning into your hands. And that's our mission at AWS, to put machine learning into the hands of all developers and all data scientists and managers for that matter. So I do have a little bit of time for Q&A. I have to admit I filled up that half hour.
No, you're good. We did have 3 questions come in. We'll see as many as we can get to. If not, we will have them answered in the follow-up afterwards. So the first question for you is from Gabe. He asked, how do you see AI predicting better in the next 5 to 10 years? And how does AWS play a role in this?
That's a really important question. I would say that 90% of the consulting time that I spend is not on the algorithms, it's on the quality of the data. So that's really good news, because what that means is if you look at the popular frameworks like PyTorch, and I'm a PyTorch bigot, I'll just say it right up front. I started with TensorFlow, but now I just pretty much do PyTorch. When I am helping folks with their problems, they expect me to come in and help them change the PyTorch. 9 times out of 10, if not, 99 out of 100, it's the data. It's the data sources. What features are you using? Can you drop some of those features? How can we create new features in the data by combining columns to create more powerful insights and feed it to the exact same algorithm? It might just be XGBoost. It could just be a statistical method. But it's really all about the data. The more we understand our data, are more intimate with our data, the more we really understand it intuitively, the more we can begin to drive better predictions and better outcomes. Now, we do have all kinds of tools in SageMaker that improve the model, and in particular, something called hyperparameters. So if you want to dig into SageMaker, we have free trials that can last up to a year. So if you're in school, please take advantage of that. We have a number of student programs available as well.
Perfect. And I think we could just, we might go a little over. We'll ask one more here. Are we able to find a sample machine learning architecture in AWS to create our own small-scaled habitat leveraging AWS free tier capabilities?
Absolutely. In fact, it's as simple as going to your favorite search engine right now and just typing AWS machine learning tutorial, getting started, whatever language you think is best. We have tons of tutorials. If you go to YouTube and do the exact same search, you'll find me showing up with a number of tutorials. We have tons of repos. In GitHub, something called AWS samples. So what I recommend is start with what you love. Start with what you're passionate about. Would you like to do object identification with computer vision? Would you like to translate the language from the country you grew up with or the dialect you grew up with and translate that into English or some other language? You could do that today with the samples that are right in AWS samples. So start with your passion. Start with where you think you're going to make money. People are passionate about that. And there's almost always something there. And if not, I believe the next slide is my contact info. There we go. Send me an email and I'm more than happy to help you find what you're looking for.
Perfect. We are right on time there. So thank you so much, Chris, for joining us today.
Thanks for having me.
No problem.